What's going on, guys? Welcome back to this video. In this series of videos, we're going to talk about Tshark, and hopefully this will be a comprehensive guide for you to get started with network analysis using this command line tool. So first, let's start with the definition of Tshark. Tshark is a command line version of Wireshark. It's like Wireshark comes with GUI interface. Simultaneously, we have Tshark comes as a command line tool. And by the way, Tshark has been created and developed by Wireshark team. Now, Tshark can be used to capture traffic and analyze PCAP. So here we come to the use cases of Tshark. First, we capture traffic, we sniff traffic based on the available network interfaces. We will come to the available command line switches later on, and we can use this to read PCAPs and analyze them. Very much similar to Wireshark. Remember, in Wireshark, in the GUI interface, there is a mode called live capture where we can start capturing traffic. At the same time, we can import a file and analyze it using the display filters. Likewise, in Tshark, it can be used to sniff traffic based on the available network interfaces, and can be used to read capture mode or capture files as input files in order to analyze and extract insights. Okay, the next are the filters. So basically, same as Wireshark, again, we have two types of filters. First one is capture filters, and next we have display filters. And I want to remind you guys the difference between capture filters and display filters. Capture filters can be used while sniffing traffic, meaning they can be used in live mode. That's what they are called, capture filters. They are used during capturing the traffic. However, display filters can be used while analyzing a PCAP file. Okay, that's the main difference between them. While capturing or while sniffing traffic, we have to specify the capture filters before we start sniffing traffic, because we cannot do that after we run the sniffing process. However, in display filters, we can actually interrupt the process and adjust the display filters in order to fit and adapt to the current situation. We're gonna now go ahead and explore the basic command line options used in Tshark. Okay, so first we can start Tshark using Tshark-H. Here we can summon the help menu. It's very important to get yourself familiar with the available options displayed here, and to get back to help menu whenever you need assistance or whenever you are stuck and we don't know what is the option that will fit in the current scenario. Okay, now next we have Tshark-V. Using Tshark-V, we can see the available version of Tshark. In our case now it is 3.2.3. Okay, now going back to the board here. So remember that Tshark is a command line tool, which means we're gonna have to get ourselves familiar with the available options. Now, we have options for sniffing traffic, and we have options for the PCAP analysis. We have first to decide what is the mode of operation we want Tshark to use with. Is it sniffing or is it PCAP? Because both modes have different running commands. Let's go back to the command line. Before we start, let's say sniffing traffic, we want first to explore the available network interfaces. We can do that using Tshark-D. With this option, we can view the list of the available network interfaces. In our case, we have 12 network interfaces, and as you can see, they are numbered because the numbered listing of these network interfaces will help us in selecting the network interface while sniffing or before sniffing. For example, let's say I want to use the second network interface, the loopback. How can I use it? Tshark-I, and then I put in the number. I will plug in the number of the network interface. In the case of the loopback, it is 2, so I put 2. And if I hit enter now, Tshark will start sniffing traffic that is passing through this interface or captured by this network interface. All right, now what if I just run Tshark as is without selecting any network interface? What's going to happen here? Tshark will start sniffing the traffic based on the available network interface among the list of the interfaces. Basically, to be accurate, Tshark will go through the list of the network interfaces starting from the first one. If it is available for capturing traffic, it will start sniffing the traffic using the first network interface. If you don't want that to happen, you're going to have to specify which one to use using -I followed by the number of the desired network interface, or by just typing the name of the desired network interface. In case you want to use Cisco dump, you just type -I Cisco dump. Okay, Now we know how to deal with network interfaces and how to start sniffing with the available network interfaces. Let's now go through the main parameters. Now, let's say I want to start analyzing PCAPs. Usually, when you run Tshark in sniffing mode, you would do this Tshark, let's say -I, and I want to use the first network interface, so I use 1-W. Here I want to specify an output file. Let's say it is file v2.pcap. Now Tshark will start sniffing the traffic, saving it to file version 2 pcap, and then closing. So now I'm going just to interrupt the process. Sorry Tshark, I'm gonna interrupt you now. ls, now I have two files, file v2 in addition to the available demo file. Okay, now here comes the next stage. Let's go back. So we finished sniffing traffic. Now we're gonna start analyzing the PCAPs. So we have two PCAPs, file v2 and demo. Let's say you want to start the analysis. The first option you have to get yourself familiar with in case you want to start PCAP analysis is tshark-r followed by the name of the file. The main option here is -r. Okay. Now, let's say you want to list a specific number of packets. Let's say you want to list only 10 packets. So you would use -c in this case and 10. What's going to happen here, as you can see, Tshark listed the first 10 packets that were captured because we specified the number explicitly here using the -c option. Okay. Now, there is one thing we forgot to mention here is the verbosity mode. Tshark-v. The -v will provide detailed information about every single packet. So in case you are using this option while doing live capture, as we did earlier, it's going to overwhelm the output. Even if you were using -v while sending the output to an output file, it's gonna overwhelm the file, and you will see a lot of details with every single packet. It's very recommended to use the verbosity option in case you want detailed information about the packets and simultaneously you know which packets you want to narrow down. Let's take an example here. Say Tshark, okay, -r, -c, let's say the first 5 packets, and -v. Look at this mess. See now, as you can see, we have detailed information about every packet, the hex, the decimal representation, the ASCII representation. Now, it's very recommended, guys, to view them packet by packet. You can start with the first packet. As you can see, we have detailed information about the first packet. See now, it is packet or frame number 1. And we have similar detailed information that can be viewed also using Wireshark. You see in the packet details, this information can also be viewed using the packet pane in Wireshark GUI interface, right? So this is a detailed view of the packets, right? Let's say that you want Tshark to run Tshark on network interface, maybe the first one, and you don't want the output to overwhelm the, the screen or the output. So what you can do, you can use -q to run Tshark in silent mode. This will capture traffic without any noise. And lastly, you can also display the packets in hexadecimal representation. Let's say you want the first packet with hexadecimal representation. You can use the option -x. And see, we can have hexadecimal representation of the packet. Okay, now we have learned about sniffing mode and about PCAP analysis mode. Let's now talk about some filters here. Remember, we talked about two types of filters that can be used in Tshark as well as in Wireshark. They are capture filters and display filters. And remember that, or recall that, capture filters can be used with or while sniffing traffic. However, display filters can only be used during PCAP analysis. Let's go back and lay down some examples here. Okay, now let's say we are in live traffic. Okay, so let's go back here and let me see some examples here. So on capture filters. So in capture filters, remember that we have to specify the relative option here. So it is -f. With -f, we are using capture filters. And after -f, we follow it with the operator. So in case I want to filter a host and an IP address, I use the host followed by the IP address. Note the double quotes here. We use double quotes all the time when we use capture filters. On the other hand, in display filters, we use single quotes. single quotes, and here comes the operator. In capture filters, we use double quotes. So double quotes, and here comes the operator. Going back to the example here, so Tshark-F, it is a capture filter, and then double quotes. Between the double quotes, we have host and an IP. In the other case, we have network range and the IP of the network range followed by the subnet mask. Don't forget the CIDR. In case it's a port and the number of the port range, the range of the port, source IP, destination IP. You get it. You can go back to the documentation of Tshark to find more available, capture filters. Let's go back to the example here and see how we're gonna simulate this. So Tshark, okay, -I, the first network interface, -F, and then here comes the operator. Say I want to filter using host IP address. So host followed by an IP address. Okay, what's going to happen now? Tshark will start sniffing the packets where the host IP is 410s, whether it was source and or destination. It's going to capture all the traffic mentioning this IP in both directions, source and destination. Let's go here and simulate some traffic targeting this IP address. So let's curl the web page that's hosted on this IP. If we send some traffic accurately saying HTTP traffic, we're going to see here the capture process in real time. As you can see, all the packets that are being captured have the IP address that we addressed in the filter. Sometimes it is a source, it is a destination, other times it is the source IP address. Okay. Now let's say that we want to use other filter. Maybe we want to use the destination filter. Let's say we want to capture the traffic or the packets sent to this IP address, meaning I want this IP address to be as the destination IP address. It's gonna have to be a destination IP. So here I go back to the command and I use the keyword destination. Going back here, send HTTP requests to the web page, and now as you can see, less number of packets than in the previous example, because now I am filtering only the packets that are sent to this IP address, not the packets originating from this IP address. Here I have, as you can see, around 8 packets. Okay. Let's say I want to filter using the port. So I can use Tshark instead of host. Here I can use port. And here we can say 80. Let's send more. As you can see, we have many packets being captured in real time where the port is always 80. Of course, you can run this in silent mode by using the -Q. Right now it's running in silent mode. Okay, now we talked about some of the filters or of the capture filters, accurately saying. Let's now talk about the display filters. Remember that display filters are used only in or during the PCAP analysis. So now, assumingly we have finished capturing traffic, we have finished sniffing around, now it's time to analyze what we have just captured. So we finished the capturing, ls, we have 2 files, now we can start the PCAP analysis mode, and therefore we're going to have to get used to using display filters. Right, so how to use display filters? Remember that display filters, they can be used in a similar fashion to the capture filters. The first difference is that in display filters, the operand here, or the operator, let's say it's operand, is enclosed using single quotes. Remember this. We saw that in, let me use another color here. In capture filters, we specify that using the option -F, lowercase f. In display filters, we use the option -uppercase y. That's the 2 main differences between the filters while using the command line. So let's go back and see some examples. So again, we have the current PCAPs here. Let's say I want to use Tshark -r and the demo file that we have, and then let's say I want all the packets that have a specific IP address as a source or as a destination. Remember that, let's go back. Remember that display filters are the same as the display filters used in Wireshark GUI. So your reference in this case is the Wireshark documentation to get yourself more familiar with more filters. So tshark, and now the file is specified dash uppercase Y, 2 single quotes, IP address. And next we have the double equal operator followed by the desired IP address. So let's say 65.208.228.223. Now I have all the packets where the IP address here is either destination or as a source. Along with the packets, I can see the number of each packet. Sometimes you want to get a numbered list of the packets. So what you can do here, you can use the option -NL. See here, the numbers are kind of different. So the number on the right here, or the right column, represents the packet number. Okay, while on the column on the left represent a chronological order of the packets, which allows you to determine how many packets you have just extracted. As you can see, if you go down, the number of extracted packets is not 43, it is 34. That's why we use the option here -NL. If we don't use -NL, going back, you can see it is 43, but the number is not 43. These are only the they represent the packet number in the packet capture file. Okay, let's say I want to use a port number. So we can go back and replace IP.address with TCP.port followed by the desired port. Let's say it is 3372 and we get the same number. Let's say it is 3371. We get only these packets. See, the first one is the first packet is 18. The next packet is 24. That's a proof here that the numbers here do not reflect the chronological order of the packets. Move on to analysis using tshark. In this section, we aim to analyze the packets. So when analyzing packets, we aim to extract multiple artifacts or information, such as the streams. Remember, in Wireshark, we can follow a packet to view the stream. We can follow the TCP stream. Well, how we do that in this tool, the command line version of Wireshark, that is tshark. So basically, again, we're going to use the option -Z. And -Z will be followed by the keyword follow. Okay, so -Z follow, and then a comma, followed by the protocol we want to follow. In case the packet is a TCP packet, the keyword here will be TCP. So this will allow us to follow a TCP stream, the TCP stream of a specific packet. Now, it's not over yet. We have to specify the format. Is it a ASCII or in hex? We can use ASCII to specify the format of the data we want to view, and then we need to specify the stream number. All streams start from 0, 1, 2, 3, much like in arrays or dictionaries in the C language. When you want to access an index, you start with 0. So here we have to specify the stream number. Of course, the analysis phase is a phase that you actually arrive to later on. Before the analysis, you will have done the stats, you will have done the field extraction, you will have dealt with the filters, you know what you're doing, right? So it's going to be easy for you to specify which stream you want to follow. So let's say here we want to follow the third stream. It's going to be 2, index 2, and then we can choose to use the option -Q as well. So that's how we follow the TCP stream. Now, of course, if you want to follow a UDP stream, we have to replace TCP with UDP. Again, if you want to follow, if it was an HTTP protocol, you put the protocol here. It depends on the packets protocol. Okay, so that's how we follow packets stream. All right, now let's move on to objects. Remember, in Wireshark, we can extract the objects of a specific packet. Therefore, we'll be able to view information such as the files, the pictures, images that were exchanged in the traffic. So basically, we do object extraction. In Wireshark, you can do that through the GUI, but again, in tshark, you have to use the command line. Now, good news is, in objects, we're not going to need to use the -Z option. So basically here, we have to use -- followed by export, and then -objects. Okay, Now that it's not over yet, again, we have to specify the protocol of the packets. Okay, so in case we are extracting HTTP objects, meaning pictures, PDF files, or attachments, we're going to have to use or specify the protocol here. Let's say it is HTTP, and then comma, and here you put the path. Now the path will be the directory that will store the objects. You put a directory on your local file system. That's how we extract objects. Let's now move on to credentials. How do we extract credentials? By credentials, we mean the plain text, clear text credentials, not encrypted. Now we do that, again, we're going to have to go back to -z with -z, and then we put the word credentials. We continue the word till the end. Lastly, let's talk about some advanced filtering. In advanced filtering, we aim to do field extraction and conditional extraction. Let's talk about field extraction. Field extraction, as the name implies, it is extracting the data inside specific fields. For example, let's say we are interested in extracting the source ports or source IP addresses. First, we have to find out what is the field. Now, assumingly, you know what are the fields, the distribution of fields and the packets from the previous analysis we have done. Okay, so in the field extraction, after we specify the field, we can use advanced field extraction by using the -t option followed by the keyword fields. Here we indicate that we want to extract fields. It's not over yet, so we follow that with -e, and after -e, we plug in the field of interest. In case I want to extract source IP addresses, the field is, for example, ip.source. And then if you want to customize the filtering a little bit more, you can specify the packet number with the option -c. We can specify the packet number. Let's say I'm interested in packet number maybe 4. Using this, I will be able to extract the IP or source IP addresses in the first 4 packets. This will give me the values. Remember, this will give you the values of the source IP addresses. Similarly, you can do the same with other fields. For example, let's say you want to extract destination IP addresses. You can do that in one command. You don't need to execute 2 commands. With the same command here, you can add additional -e and put in or plug in the field of interest. It could be IP destination. All right, so now let's talk about conditional extraction. Here, we extract data from packets based on a condition. Now, how to specify a condition in Tshark? We can use that using 2 keywords. Okay, the first keyword is contains, and it's a popular keyword in all, programming languages. Additional programs use contains to filter. The other one is we have contains and we have matches. Okay, so that's for conditional extraction. How do I apply this? Okay, let's have an example here, and let's use the black color. Okay, remember that when we do conditional extraction, we actually deal with display filters. Remember that display filters can be used or can be summoned using the -y, uppercase Y. We just use display filters here. So let's start with contains -y, okay? And then we have 2 single quotes. Remember, in display filters, we have to specify the condition between 2 single quotes, not double quotes like in capture filters. Okay, now we have the word contains. The word contains comes in the middle. So here we have contains comes here. And after contains, we use 2 double quotes. Inside the double quotes, we plug in the keyword we're looking for. Let's say I'm looking for Apache servers or packets where Apache keyword is mentioned in the request headers. So I put here the keyword Apache. Whatever, you continue to the rest. And then before the contains, here we have the field from which we are extracting the data. In case we're extracting Apache, Apache should be in the HTTP headers. But which header exactly? What header that will contain the server? It is HTTP dot, we have dot here, and server. So this goes here. When you execute this, what's going to happen? Tshark will extract all the packets where the value HTTP header equal to Apache. Therefore, you have all the packets where the server is Apache. Let's now move on to matches. So with matches, the case is kind of different here. So again, let's start with the option -uppercase Y. And then we have two single quotes. Between the single quotes, again, we have the keyword matches comes in the middle here. Now, what comes after the matches is the keyword we're looking for. Now, matches condition will let Tshark look exactly for the keyword, for the exact match of the keyword. In case I'm looking for get requests, okay, it will only extract get requests. It is exact match. Remember to put the exact match of the keyword you're looking for. That's after the matches. Before matches, we have again the field. Now, get is actually one of the HTTP requests. So it should come as a value in the HTTP headers. The header that contains the value of the request, it's going to be HTTP dot request dots. It's going to be the method. That's the method of the HTTP packet. This one, this is the field name, comes before the matches. Okay, so this one comes here. Now the field comes before the matches and get. We're going to see how this looks like in the practical scenario. Right, in the next section, we're going to talk about how to use Tshark to extract insights, such as statistics about the packets. As you can see here, there are certain types of stats that we can extract. First, we have protocol breakdown. Next, we have packet tree length, endpoints breakdown, conversations, and IP protocol tree. Now, basically, all of these stats, if you remember, guys, can also be retrieved while using Wireshark. They are the same features that can be accessed through Wireshark. Instead, here we are choosing to use Tshark, the command line tool version of Wireshark, to extract these stats. The very important thing about these stats, they all can be used using the -z option. So the -z, of course, it's lowercase, followed by the filter will enable us to choose the type of stats we want to extract. Let's have an example here. So if we go to the machine, and here, remember that we have the, let's go to the directory where it has the Wireshark file, okay, we have the, okay. So here we have the PCAP files. Most importantly, we're going to analyze the demo one in addition to the DNS and the host names. So let's start with tshark-r demo and then with the -z option. So -z help. When we use that, or when we just type tshark-z help, as you can see, these are all of the available filters we can use with the -z option. Here we can choose, as you can see, among the filters, we can display stats about the endpoints, about the conversations. The conversations are the flow of packets between endpoints or IP addresses. So it depends on our objective. For example, if we want to choose the protocol hierarchy, tshark-r demo, and again, we have -z. Now, from the list here, we're going to have to choose the IO here. IO will enable us to view the protocol or the protocol hierarchy here, depending on the packet size. We will have a tree of the protocols broken down based on the packet size. We can use IO stat or IO PHS. So let's see here, IO dash or comma PHS. As you can see, we have them in a tree-based view. First, we have the Ethernet. We have around 43 packets. IP packets are 43, TCP 41. HTTP packets, we have 4 packets. As you can see, all of the protocols are viewed based on the number of packets. You can also use the option -q to have a just summary. In the above view, we had the details. So in addition to the summary, we have the packets extracted based on the filter. But with using -q, we are choosing only to display a summary of the statistics, protocol hierarchy statistics. So here we can start with this filter if you want to get information about the protocols involved in a packet capture. All right, so let's say we want to focus on specific protocol here, UDP, HTTP. What we can do here, we can use the same command, but after the PHS, we're going to have to specify the protocol we have chosen. In this case, let's say it is HTTP. So now you can see, guys, the breakdown or details about the HTTP protocol. As you can see, we have XML. We can also choose to use DNS. So no more details about DNS. You can choose UDP, and it will give you the stats about the UDP protocol. So under UDP, we only have the DNS, and we have 2 DNS packets. Actually, the total number of UDP packets are only 2, and they are composed of only DNS packets. Okay. Now this is the protocol breakdown. Packet length tree. Okay, so in case we want to get a general distribution of the packets broken down by size, we can choose to use another option here. So if we go up here to the list of options, or we can just resummon the help menu, and scrolling up, let's see. Okay, so plain tree. This filter will enable us to view the general distribution of packets based on their size, of course, in a tree view. So here we're gonna use -Z, plain tree, and of course use -Q to display a detailed view only. All right, let's take a look here. So as you can see, we have multiple columns. First, we have the packet lengths. Of course, here the packet lengths start first, and then we have the count of packets, the average, the minimum and maximum value, as well as information such as the percentage. Let's take a look at this one. So here we have 22 packets, okay? They are occupying 51% of the overall packets, and the packet lengths are between 40 and 79. These are information about the packet lengths. Now, let's move on to the endpoints, how to view the endpoints. So basically the endpoints are the IP addresses, right? When we choose the endpoints, we technically want to display a tree view. This view will show us the number of packets associated with each endpoint, meaning with each IP addresses. Again, how to view these endpoints, we're gonna have to go back to the -Z help menu and see if there is an indication of an endpoint filter here, scrolling up. So we have all the endpoints here. Now, depending on the protocol we choose, the filter will follow. For example, we can choose endpoints IP to display the endpoints based on IP addresses, which is the most common used filters here. Let's use that. Okay, -Z, endpoints IP, and of course, -Q. Here we can see the IP addresses, the endpoints, of course, they're IPv4, and the other column we have the packets, the size of the packets, and other useful information. For example, these we have 4 endpoints indicated by their IP addresses, and along with every endpoint, we have the number of packets exchanged and the size of each packets. These are merely statistical information. Okay, let's go back. So, done with endpoints, let's now turn to conversations. The conversations help us to view the traffic flow between endpoints or 2 particular connection points. Basically, when you choose to extract insights about the conversations, you choose to actually view the direction flow or the traffic flow between IP addresses or between endpoints. Again, we're gonna have to use the Z option here. So -Z, and in case of conversations, it is conversation, and he would choose it. It's gonna be based on IP -Q. As you can see, this is the flow of the conversations. So we have this flow between this IP address and this IP address, along with the number of packets, the bytes. Also, we have this between these 2 IP addresses. So along with the traffic flow here between the IP addresses or endpoints, we get to see the number of packets and the bytes. Now, if you go back to the help menu and extract conversations, we have other options as well. So we chose the IP address filter. We can also use other filters such as TCP. Let's choose that. So if we choose to use TCP or the protocol name, we can see the direction of traffic based on the protocol. And here we can see the port numbers. So here, this is the source port, and this is the destination port. Okay. All right. So another thing now we're going to have to take a look at, we are still talking about stats, is the IP protocol tree. We want to view tree-based view of the IP addresses, whether it is IPv4 or IPv6. To do that, again, we are stuck with the -z. So it is the -p type, the protocol type, and we choose to display it in a tree view. Let's try it. -z, p type, tree-q. So now we have, as you can see, the IP protocols involved in the packet capture we have chosen. We have TCP and we have UDP. For TCP, we have 41 packets, and for UDP, we have 2 packets. Now, if you want to focus on, as you can see, we couldn't find any occurrences of IPv4 or IPv6. So if you want to focus on IP addresses instead, you can just modify the filter, and here choose IP hosts viewed in tree-based. As you can see now, we have a tree-based view of the IP addresses along with the number of packets. Now, of course, this is IPv4. If you want to see IPv6, you're going to have to go back and add v6 here. Now, in our case, we don't have IPv6 in this packet capture. Sometimes you want to view IP addresses based on the direction of the packet, meaning you want to see source or destination IP addresses. In this case, we're going to go back to the command, and here we're going to have to add the word, remove the hosts, and add source destination. Look at this. We have the source IP addresses along with their packet counts, and the destination IP addresses along with the packet counts. Same thing with IPv6. All you have to do is to add v6 here. Of course, we don't have IPv6 in this packet capture. Okay, now if you want to focus on or extract statistics about protocols, you're going to have again to use the -z option here. So -z, let's say the protocol of choice is HTTP, and then we choose to display the output in a tree view, and -q. This will give us stats about the protocol in a tree view. Total number of HTTP packets, we have 4, along with the dissection here. So we have the response packets too. 2 of them are success, and we don't have any errors. So you also get statistical information about the response and the status of the packets. You can also use DNS. So in case of the DNS, we have 2 packets. The query type was a record. So 2 DNS packets to query a records. Okay, so that was the summary about statistical insights using Tshark. So now let's go over some practical scenarios. I have prepared some practical scenarios for this demonstration. Specifically, we can go over the Tshark, the basics room in TryHackMe. Okay, I'm going to assume, guys, that you will be good to go with the explanation we have just covered. I'm not going to go over every single task. I'm only going to explain the answers. Let's start with task 2. Okay, this one is about using cap infos, right? I'm not going to cover this one. The other one, what is the installed Tshark version in the given VM? So you know now by using the option -v, you will be able to find out what is the version of Tshark. If we go up, this one is a very easy one, but I'm going to assume that there are some people who are just getting started with Tshark. Anyway, let's do it. -v. So use -v, you'll be able to find the version. This one is very easy. If you cannot find it, it's a problem. List available interfaces with Tshark. What is the number of available interfaces in the given VM? Remember, we used the option -d in Tshark to be able to find the answer. Task 4. Read the demo file. What are the assigned TCP flags in the 29 packet? All right, this one requires me to go over the this from scratch. So Tshark -r demo. The packet number 29. Okay, we can see the TCP flags, their acknowledgement and push. What is the acknowledgement value of the 25 packet? Highlight the 25 packet. We can see the acknowledgement number is equal to 12,441. 21. مكعص عن أبوك يا زلمة، كسرت الدنيا مشانك. What is the window size value of the 9th packet? The window size. So this is the 9th packet, and we can see the window size is 9660. Okay, task 5. Which parameter can help analysts to create a continuous capture dump? Oh, looks like we haven't covered this one. Can we combine auto stop and ring buffer parameters with Tshark? Okay, let me explain this. So basically in Tshark, what you can do, you can run a continuous capturing loop, which means you can run Tshark indefinitely. So by using, we have two options to accomplish this. We have -A and we have -B here. Okay, now with -A, we can run Tshark for a specific duration, or we can run Wireshark until the output file specified by -W reaches a specific size. So with -A, we can specify a condition for how long the capturing will continue. On the other hand, using the -B, we can continuously let Tshark sniff packets. How it's gonna happen? So basically, we can specify the same criteria here. We can specify duration here, and we can specify size here. However, when the output file reaches the specified size, or when we reach the maximum duration, Tshark, with the option -B specified, will create a new output file and run the operation or start over. Okay, let's see an example here. All right, let's take a look at this one. This Tshark-W test PCAP-A duration 10. This will run Tshark, okay, sniff packets for 10 seconds and store the output in the test PCAP. After 10 seconds, Tshark will not be running. Let's go over this one here with the file size. So here we are using the file size as the criteria to run Tshark. Here, Tshark will stop sniffing when the file size reaches 500 kilobytes. Let's look at the -B and why it is going to run Tshark in a continuous mode. As you can see in -B, we use the same filtering criteria, file size or duration. However, after we reach 500 kilobytes, what's going to happen here, Tshark will create a new PCAP file. So first, it's going to create a PCAP file with 500 kilobytes. When it reaches 500 kilobytes, meaning the PCAP file, it's going to create a new PCAP file, meaning it's going to run indefinitely. Going back to the answers, which parameter can help analysts to create a continuous loop? It's going to be -B. Can we combine auto stop and ring buffer parameters, meaning -B and -A? Yes, we can combine them. Task 6, which parameter is used to set capture filters? We covered this, -F, display filters, -Y, uppercase. What is the number of packets with sync packets? Okay, let's see here. So if you, let me clear. And as you can see here, what is the number of sync packets? Run the commands from the above terminator terminals on the target machine. All right, so here we're gonna have to run this command. Here we run Tshark in sniffing mode to sniff packets on the first network interface and to only display sniffed packets that contain the specified IP address here. Now we're going to send some traffic here. Now we get some data. Okay, how many packets with sync bytes? So sync, we have 1, 2, 2. Yep. What is the number of packets sent to the IP address? 10. Now we are addressing this IP address as a destination. So here, let's see if I have covered this. Yeah. Run this one and go back here, send some packets to the server. Back here, we have now some data. Now, how many packets we have? We have 7 packets. What is the number of packets with acknowledgement bytes? Going back, 1 acknowledgement, 2, 3, 4, 5. Oops. We have 8. 1, 2, 3, 4. I guess they mean in the first scenario here. The first time, how many acknowledgement packets do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here the question refers to the first scenario where you are filtering packets that contain the IP address here in both directions. source, and destination. Okay, the last task. What's the number of packets with this IP while analyzing this file? So now in PCAP analysis mode, yeah, I guess we covered this. So here we are using, again, I'm not going to explain this over, guys, because we explained this in the theoretical part. Let's now answer the question. What's the number of packets with this IP address? As you can see, on the left column, there are 34 packets. What's the number of packets with a TCP port 3371? Have we covered this? Let's find out. We have covered this, okay. The answer is, what is the number of packets? The number of packets, we cannot find out. We can have to use dash pipe NL. And we have 1 till 7 packets. What is the number of packets with this IP as the source? Okay, now, so here, let's copy this IP address. Paste, and here use source or destination. It is the source. Now we have a problem. Neither source address nor are field or protocol names. Okay, I got you. Okay, so here, this one has to be, let me move this one. It's a mistake in the display filter. So here it has to be IP.source. And now we have 20 packets. Rerun the previous query and look at the output, meaning this one. What is the packet number of the duplicate packet? Duplicate packets come with keyword duplicate. To extract the answer without having to look through all of this, all you have to do is to use, the answer, grep. And grep will give you what you want. So we have this packet with duplicate in the TCP acknowledgement flags, and it is packet number 37. So the other practical scenario I want to discuss in this course is the other room, TShark CLI Wireshark features. And I'm going to go over the tasks, of course. I'm going only to answer the questions. So in task 2, scroll down all the way down. Right. Use the write demo PCAP to answer the questions. What is the byte value of the TCP protocol? So we go to the available PCAPs, and do we have a write demo? Indeed, we have one write demo PCAP. So the question here is to extract the TCP, the byte value of the TCP protocol. In this case, we're going to have, again, to list or extract insights, specifically statistics about the TCP protocol in order to answer this question. So tshark-r, we specify the PCAP file. It is write demo PCAP, and then with -z, IO, phs-q, we display protocol breakdown. As you can see, guys, we have only TCP protocol here. So we choose TCP, and we cancel the detailed view. The question here is asking, what is the byte value of the TCP protocol? As you can see, it is 62. And this can also be found using the detailed output given above here. So we have TCP protocol, and the byte value is 62. Okay, in which packet length row is our packet listed? In which packet length row is our packet listed? As you can see, it's listed in packet number, packet length. All right, so here we're going to have to view the packet lengths this time. So to do that, remember when we talked about the stats and the filters, we're going to have to use a -z again, len 3-q. So in which packet length is our packet listed? As you can see, since we have only one packet, it is listed in the 4079. So 40. What is the summary of the expert info? Yeah, about the expert info. So the expert info can be viewed as well in Wireshark, and it is a very highlighted feature in Wireshark that enables you to view the automatic comments provided by Wireshark about the packets. We can achieve that as well with tshark. So tshark-r write demo, and then to view the expert info, we use -z expert-q to have a detailed view. And here we can see the summary. In the summary column, we can view the comment or automatic comment provided by Wireshark. Connection established request. All right, what is the summary? Let's copy all of this value. Okay, use the demo PCAP to answer the question. List the communications. What is the IP address that exists in all IPv4 communications? Enter your answer in defunct format. Okay, so just the communications, we're gonna have to view the conversations then. So tshark-r demo, and to view the conversations, remember we're gonna have to use -z, specify the conf, and then followed by the type of operator here. So the operator is gonna be IP, or the filter is gonna be IP because we want to focus on IP addresses, have a detailed view, summarized view, and we have the IP addresses. All right, this is the communications. What is the IP address that exists in all IPv4 conversations? So we have the first IP conversation is between this IP address, starts with 65 as a source, and as a destination, we have 145. That's the first conversation. The next conversation is this one, and also contains the IP address, but this time as a source, starts with 145. And in the last one, or in the last conversation, we have this IP address that ends with 237 being the destination IP address. So that's the IP address that appears in all the conversations. CyberChef, we don't know why, because we want to have a defunct format. So defunct, copy that. Okay, task 3. Okay, so what do you have in task 3 here? Use the demo PCAP file again. Okay, which IP address has 7 appearances, and enter your answer in a defunct format. So again, we're focusing on IP addresses. Clear tshark-r demo. Let's go back here. Which IP address has 7 appearances? We can use the conversation flow, but instead we can also focus on the IP addresses by choosing to display statistics about the IP protocol. To do that, we're gonna have to use -z ptype 3. Let's see here. So we have IP protocol types 43, TCP being 41, and UDP we have 2. Right, to focus on the IP hosts, we're gonna have to use again -z and use IP hosts 3-q. This will give me breakdown of the IP addresses. So the answer to the question is, which IP address has 7 appearances? So according to the stats here, the IP with 7 appearances is this. Defunct format will take care of the answer. What is the destination address percentage of the previous IP address? So we're gonna have to find out how many times this IP address has appeared as a destination in a percentage format. To do that, we're gonna have to use the source and destination view. So IP underscore source destination. Remember our IP address is this one, starts with 216. So it is this one, and the count is 3. But we don't want the count, we want the percentage here. The percentage is 6.98. Which IP address constitutes 2.33 of the destination addresses? As you can see, we have this one constitutes 2.33 defunct format. And lastly, we have what is the average queue name length value? Okay, this one is going to be kind of tricky here. Let's take a look at the hint. The DNS stats can help. Yeah, this one is part of the DNS protocol. So clear -z DNS3-q. This is the queue name length. The question is asking, what is the average queue length value? Let's take a look at the columns. This column indicates the average value. In case of the queue name length, it is 29. So now let's continue with task 4. In task 4, we're going to have to, again, open the same PCAP file, and this time we're going to follow the UDP stream 0, the first one. Okay, let's now execute the command line, and from here we're going to move on to cd desktop, make sure the PCAP is here. Okay, well, I'm going to have to minimize this, zoom out. So I cannot see, guys, honestly. I cannot zoom in too much. Okay, so I'm gonna deal with this one, demo. Tshark -r demo, and we're gonna have to extract the stream 0, UDP stream. So basically, remember, to extract streams, we're gonna have to use the -z option, okay? So with -z, follow, and the protocol is UDP, ASCII format, the stream number is 0. Okay, what is the node value? What is the node 0 value? Let's take a look at the nodes. So now we are examining the stream here. As you can see, it is UDP stream, and the filter that was used to execute or retrieve the data is udb.stream equals to 0. It's the same filter, guys, you see in Wireshark. Node 0 equals to this IP address and this port. You're gonna have to copy this and answer with it. Wrong. What is the node 0 value? Enter answer in defined format. All right, so you're gonna have to go with cyber check this time. Now with defang. Let's see here. Copy this. Follow now the HTTP stream number 2. You see the index here is 1, but in fact, the order is 2. It's the second stream. What is the referrer value? Enter your answer in defined format. Okay. With the same PCAP file, all we have to do is to adjust the protocol, make it HTTP, and the stream number will be 1. That's quite a big stream here. Let's take a look at the packet. So we start with the filter, and then we have the nodes, node 0, node 1. These are the nodes exchanging the traffic. So we have the IP address here as the source, destination IP here with 99, ends with 99, and destination port is 80. And we have detailed examination of the packet. Here, this is the HTTP method. It's a GET request, along with other information about the HTTP header, such as the host, the user agent, and lastly, we have the referrer. So you're gonna have to copy the referrer, and don't forget to use defang. Defang URL. Okay, use the credentials PCAP to answer the question. What is the total number of detected credentials? Now we are extracting insights or data. So clear ls PCAP credentials is right here. tshark-r credentials. Credentials. Yeah, dash z credentials dash q. That's how we extract clear text credentials. We're looking to find the total number of detected credentials. Let's see here. All right, remember that these do not reflect the actual number. So we're going to have to use an L, numbered lines, and we have around 78. 78 credentials. Nope. 79. Let's see the hint. Use the NL command, exclude the banner lines. If we exclude this, we have 78. Let's see if there is another one at the top. We have another one. So we have 1, 2, 3. That makes it 75. Okay, moving on to task 5. Use the demo and answer the question. What is the HTTP packet number that contains the keyword cafe? Here we are extracting data, or maybe strings, let me call it string. We're extracting strings and keywords from the packets. Therefore, we're going to have to use advanced filtering, conditional filtering, and fields extraction. Remember these? Okay. All right. Clear tshark-r demo. And here we're extracting, let's see, what is the packet number, the web packet number that contains the keyword cafe. Okay. So here it looks like we're going to have to use, let's see, it is an exact match. So maybe if we use the match keyword, matches. So dash y two single quotes, and we have the keyword matches in the middle, two double quotes. Between the double quotes, we have cafe. And then we're going to have to find out a way where to find this. So before the matches, we have to put out or plug in the field. Here, we are dealing with HTTP packets. So where could this keyword be found? Let's take a look at the hint. The contains filter can help. Okay, we are using matches. Let's try both. Let's start first with matches, and then if it didn't work out, we can switch to contains. Let's try with the server field, http.server. And we can see we have a match. The word cafe has been found in this packet. We can see information such as the IP addresses involved in the transaction and the response code and the number of the packet. Let's try with 27. And it worked. So you can use either contains as suggested by the question or by the hint, or you can use matches. I use matches because we're looking exactly for the uppercase version of cafe. Right, let's move on to the next question. Filter the packets with get and post. So we have a condition here. We have to match get and post requests, all right? And extract the packet frame time. What is the first time value found? Right, let's first dissect the question. We're looking to extract packets with either get or post as HTTP methods. So here we're dealing with, we need to use a filter that extract first HTTP packets, and then we specify the condition that the packet should be get or post request. Again, we can do that using advanced filtering. So with -y option, we can use the word here. This time we're going to have to use contains. Let me go back. Looks like here we're going to have to use matches because we have two conditions, post and get. So again, use matches. To satisfy both keywords, get and post, we're going to have to use pipe. So post, and here comes the get. We'll leave matches as is, and now we move on to the field here. The field should be the request method, right? http.request.method. And we have two packets that satisfy the condition. We have the packet with number 4 and packet with the number 18. Let's see here. What is the first time value found? Let's see. Looks like we're going to have to find the answer in the next packet here. So we look at the parameters. We have a client, one of the HTTP parameters. We have random. The other parameter is format, HTML, the URL, the color border. So to find the time frame, we're going to have to use -e. Remember, if you go back to the board here, when we talked about advanced extraction, remember that we said we can use -t if we are extracting fields or -y if we are looking for conditional extraction. But remember that with -e, we can specify the field we are extracting. We go back to the command here. So with -e, if we specify frame, the time, Okay, so we forgot something here because if you're going to use the -e, we have to use the we have to use the field extraction. So in this command, we are using conditional extraction coupled with field extraction. To use them together, as you can see, the first part of the command is a conditional extraction. To extract the frame time is a field, right? In order to extract data within a field, we're going to have to use the -t option and the keyword fields followed by the frame time or the field name. The field name is frame time. Let's see if this works. And this one didn't work. Let's go back, see what's wrong. So tshark -r to PCAP -y, we're using here conditional extraction. The request method matches get post. We have enclosed the condition with single quotes, -t. We have fields here, and then -e. Oh, the -e, there is no space between the -e and the fields keyword. So use a space, and this will work out. So what's the first time value found? It is this one. Is it correct? It is. Last task, task 6. This one's quite long. All right, let's get to it. So here we're going to have to clear the mess ls to see the available capture files. Now use the host names PCAP to answer the questions. What is the total number of unique host names? So here we have to extract host names and make them unique. We have to eliminate the duplicates. Right, let's go back. So the host names PCAP is this one. So we start with tshark-r, we analyze the capture file, host names, and then -t, fields, we're extracting fields here. Let's go back. Host names, what is the total number of unique host names? To find the host names, we're gonna have to specify the protocol. Which protocol will give us the host name? So in the fields here, we have to specify the field which will contain the desired protocol. In this case, host names can be found using DHCP protocol easily. DHCP and then dot option host name. Let's see if this works. -t fields. What's wrong with this? -t fields was specified, but no fields. Okay. I just thought I was making a typo. So remember the -e option to specify the field we are extracting, right? Let's see if we have values. Yeah, now we have some values about the host names. Let's now get to the next part, which is extracting unique host names. To extract unique host names, let's analyze first the output. So in the output, we have a list of many host names. Some of them are duplicate. Another problem with this output is these spaces here. So we're gonna have to get rid of these new lines. How are we gonna do this? Let's use awk followed by nf. This will get rid of these new lines. Let's take a look at the output now. So we don't have new lines, okay? And next, let's get rid of the duplicate values, unique -c, okay? And they are numbered. Let's now sort them in ascending order. Let's take a look. But there is something wrong with the numbering. Let's go back and see what's the problem. So here we have eliminated the new lines, and then we have eliminated the duplicates, and lastly we have sorted them. How about if we sort them twice? The first time after we eliminate the new lines, so here sort -c and then -r, and after sorting them recursively, we eliminate the duplicates, and then we do another last sorting. Okay. 1, 2, we have around 26, but there are more than 26. Let's use the option -nl this time. Let's see if this will work with the numbering. Yeah, this time it works. So as you can see on the left column, we have the order. So there are 30 host names. What is the total appearance count of Bruce PC? Let's figure out what is this Bruce PC here. Let's go back and see if we can extract it. If it is among the list of the host names, grep Bruce. All right, so we have a host name named with this value. Let's see here. What is the total appearance count of this host name? As you can see, the appearance count is 12. Use the DNS queries. Answer the question. What is the total number of queries of the most common DNS query? Okay, now let's head over to tshark-r DNS. Total number of queries of the most common DNS query. So you have to extract two values here. The first one, the most common DNS query, and then we have to see the total number of queries of the most common DNS query. It's a compound question. Let's see how we're going to answer this. Let's go back. And here, look here, we picked up the DNS capture file, use -t to extract fields, followed by the -e. Since we are extracting queries, DNS queries, we can do that, or we can specify that using DNS query name. Let's see this. All right, now we have the DNS query names. Let's eliminate the new lines. Okay, now we eliminated the new lines. Let's now sort. So in similar fashion, what we did in the previous query, sort -r. Okay, so now we sorted them based on the number of occurrences. Now we have to get rid of the duplicates. So we can do that using unique-c. As you can see, now we have the DNS queries along with the occurrences. To get these sorted out, we're going to do another sorting, sort-r. So from highest to lowest. The most common one is this one, db routes edu. The number is 472. Occurred 472, or it appeared 472 times. Use the user agents PCAP now. Tshark-r user agents. And then, what is the total number of detected wfuzz user agents? All right, this one is straightforward. Let's go back and again use -t, the fields, okay, -e, and here we specify the field name. As you know, guys, most of you know that the user agent value is contained in the user agent or HTTP user agent header. So HTTP user agent. Let's see, can we extract user agents? This one is not valid. Some fields are not valid. Okay, let's see why. HTTP user.agent. Looks like this one's gonna have to be underscore. And now we have user agents. In a similar fashion, eliminate new lines, sort them in an descending order, sorry, and eliminate the duplicates along with showing the number of occurrences, unique-c, and then sort-r, another round of sorting, and we have the user agents. Let's see the question. What is the total number of detected user agents with wfuzz as the value? Let's see, wfuzz appears here 9 times. So we have 9 user agents or 9 wfuzz user agents. Is that right? No. wfuzz. Looks like we have another one. There's another one here. But they are with different versions. The first one is version 2.4, the other one is version 2.7. So the sum of these is 9 plus 3, we have 12 occurrences. What is the HTTP hostname of the Nmap scans? Enter your answer in a defined format. Okay, this one is easy, right? Let's go back, use the same command, but this time we modify only the field. We're still tackling HTTP requests or HTTP packets. This time we use the field HTTP host. And the question is asking, what is the HTTP host name of the Nmap scans? So these are the HTTP host names. What is the host name of the Nmap scans? It doesn't look clear to me. Which one? Let me go back. What is the HTTP host name of the Nmap scans? Enter your answer in defined format. How are we going to find out? Looks like we have to use another field here. So we extracted the hosts, that's fine, but I want to find out which host is the host connected to the Nmap scans. Usually, Nmap scans can be detected by looking at the user agent. So here we have another field extraction, which is -e, http.user_agent. Let's see. Will this work? Okay, let's locate Nmap. We can use grep here. Grep Nmap. And we have 2 user agents with Nmap. That's the first one. And both user agents, looks like they are the same. They belong to the same IP address. The IP address ends with 129. So it looks like this is our IP address that uses, or that actually scans the target with Nmap. So the fang IP address. Is this correct? Okay, fine. Another practical scenario we can discuss in this video is the Tshark Challenge 1 teamwork. Probably I'm going to go over this one, and there is another one in TryHackMe in SOC level 1. This one SOC level what? This is SOC level 1, yes. So this is Tshark Challenge 1 teamwork and Tshark Challenge 2 directory. Let's do both to demonstrate how to use Tshark in a practical fashion. Right, let's go over the case. An alert has been triggered. The threat research team they discovered a suspicious domain that could be a potential threat to the organization. As an incident responder or as a SOC analyst, the case was assigned to you. Inspect the provided PCAP and create the artifacts for detection tooling. Your tools are TShark and VirusTotal. Answer the questions. Investigate the connected domains. Investigate the domains by using VirusTotal. According to VirusTotal, there's a domain a marked domain as malicious, suspicious. Okay, let's first make sure the case files are here. CD desktop. Okay, this is the teamwork file. Let's start the analysis. What is the full URL of the malicious, suspicious domain address? Here we're looking to extract, as you can see, guys, URLs, which means the protocol we're going to have to extract data from is the HTTP protocol. Let's start with Tshark. Again, I'm going to have to zoom out because this is too much zooming in. -R. The file name is teamwork. Right, so to extract the URL, the full URL, let's first specify a filter. Remember here we are using offline PCAP analysis, which means the type of filter we're going to use is a display filter. In this case, we can use -Y to indicate we're using a display filter, and display filters come with double quotes. Remember this. So let's first have a look at the DNS queries. DNS query, and then .name. Let's see if we get any data. Okay, so as you can see now, we have all the DNS queries. Let's go up and take an example. The first one, packet number 29, we have a DNS request from this IP address to this. The DNS request highlights an A record, and it is asking for this address. As you can see, we can see the full URLs here. And there are other records as well. We have DNS fourth A records, but all of these records contain the DNS query names, the DNS servers that were contacted to resolve a query. Likewise, we can actually extract these using the option -T and then specify fields -E DNS query name. Probably we're going to get the same output. Yes. But it is not neatly filtered. We're going to have to use the same strategy. Remove the new lines, sort, and then eliminate duplicates. So these are the DNS queries. Okay. It's also very useful to have a look at the protocol hierarchy here. So let's see what are the useful comments here. Let's start with the analytics. Let's have a look at the protocol hierarchy here. Remember that we can use the -Z option to extract information about the protocols. Let's go back and use this. Let's take a look here. So most of the packets are HTTP packets. We have around 48 packets, and also we have UDP packets, around 33 frames here we have. The others are TCP. Okay, how about we focus on HTTP? So -Z, here we use the protocol HTTP, and we select tree-based view. Let's take a look here at the stats. So we have around 48 HTTP packets. Okay, now let's see if we can extract the URL. So tshark -R, okay, and then we use the -T fields -E HTTP request URI. Okay, we have some URLs. Let's now sort them. An F, and then sort -R with another unique -C sort -R. These are the URLs. Okay, the question now, what is the full URL of the malicious suspicious domain? Let's take a look at the domains here. Okay, these are the URLs. Now take a look at this one. There's a request to PayPal, but it is in the parameter. So the web page that was requested is this, TBR, and the parameters are client. Looks like this is a channel, features, queue, this is a query, and we have here what looks like a URL. So paypal.com, Looks like this is our URL. Okay, so now we have the URLs, and previously we have filtered the DNS queries. But now, before we answer the question, let's also have a look at sample of HTTP packets. We can do that using tshark, specifying the file, again, -y, a display filter to filter out HTTP packets. And let's use a Linux command, which is less. As you can see, they start with packet number 45, the HTTP packets. And here we can see all of the HTTP packets. So we have a request, get request, and then we can see the responses. And we can also see the URLs. And this is the URL of interest. As you can see, the domain, the suspicious domain, appears within the URL parameters. Looks like this is a URL redirect vulnerability or attack. Now it's time to extract the URLs along with the host names. Let's go back to the first command we have used. So here, let's see, where is this one? Yeah, here. So in this command, we have specified field extraction option along with the specified here. So we extracted the URLs, but URLs are half the story. We need also the host name. So to do that, we can have to specify another field, which is http.host. And now we can see, guys, look, you can see here all the URLs along with the host names. So this is the host name that was requested, and this is the URL. The same host name here was also requested along with the URL. This is an enough looking suspicious domain, right? Let's have a look here and define the URL. So we go to Cyber Chef, remove this and go to URL, paste in the URL, put HTTP, and this is your answer. Okay, when was the URL of the malicious suspicious domain address first submitted to VirusTotal? Okay, now we have to go to VirusTotal. Whenever it goes to VirusTotal, I know it's going to be easier. So we paste in the URL. We need the original form. Let's see when it was first submitted. We can do that by going to details and have a look at the information here. So under first submission here, the field of first submission, we can see the value, date and time. So we can copy this and answer with it. Which known service was the domain trying to impersonate? Let's go back. It is PayPal, right? This is the original PayPal domain. But there are extra bits added to the original form, which are these. They start with 4 and end with another .com. So this is the modified form of the original domain. Therefore, we can safely say that the impersonated domain is PayPal. Maybe impersonated corporation, let me call it. What is the IP address of the malicious domain? Okay, and enter your answer in defunct format. Okay, let's go back. Now here we know that this is the malicious domain. It's now time to extract the IP address of this malicious domain. You can do that either by using whos tools. This will only work if the domain is alive, but if it is not, we have to do it through tshark, and that's what we're required to do here. We have to extract insights using tshark. Don't do it using online tools. Let's find the IP address of this DNS name. Looks like here we're gonna have to turn to DNS packets. Let's go back to the same command here. And here I'm gonna have to have a look first at the DNS packets. So use DNS protocol here and have a look at the DNS packets. These are the DNS packets. And here we can see that the requests to the malicious domain are DNS-A records. So this is the query name. And another piece of useful information is the query name and the type of record. Let's see if we can extract these details separately. So here we use the same command here. This time we use DNS query name, and another folder is the DNS, the A record. Why A record? Because A records are records that show the requests to the domains. They map domains to IP addresses. That's why we choose A records here. Let's see. So we have 14 query name requests to this domain. And here we got the IP address. Okay, now this is the IP. All you have to do is to copy it and go to CyberChef, defang it. Wrong. No, right. What is the email address that was used? Enter your answer in defanged format. Now we're going to have to extract the email address. Right, so to extract the email address, we might be tempted to think that we have to try looking into SMTP packets. But unfortunately, if we go back here and take a look at the protocol breakdown, we don't see any SMTP packets. Let's recall the command. Yes. Are there any SMTP packets here? SMTP protocol? We don't have. So how in the heck we're gonna find an email here? To do that, maybe we're gonna have to use conditional extraction. Look for a pattern, right? Usually emails come with @ symbols. At Gmail, at Yahoo. That's the pattern we're looking for here. Okay, but how are we gonna do this? Let's examine the full TCP packets here. We can start with TCP. So let's say the protocol here is -y TCP. Okay, this is gonna be a tricky one. We're gonna have to use a regular expression at the end. So since we don't have an SMTP protocol in the protocol hierarchy here, so we don't know where to look, right? That's why it's a good idea to dump the full packet capture into a text file and use regular expressions. How are we gonna do that? We can use -v repository and forward the output to an output file. Let's say it is email.txt. Let's have a look at email.txt. I like to use a GUI text editor. Okay. All right. Maybe we can use Control F and search for @. We have one @ here, but this is not a practical method. Maybe you can look at Hotmail. All right. No Hotmail emails. And we have a machine that is stuck now. Let's try with Gmail. Oh, there is one. There is a match on Gmails here. So let's take a look here. An email, johnny5alive@gmail.com. This email appears as part of a HTTP packet, as you can see, and it's part of a request to the malicious domain we have discovered. It's used in the login page. From item, user equal Johnny5alive. Let me tell you something here. You can actually find this email by following the stream, but we don't know which stream we have to follow, right? There are thousands of packets here. That's why it's very useful to dump the full packet capture into a text file and use maybe regular expression, pattern matching as we did. So that's the email. Gonna have to copy this and go to CyberChef, defang. Are we gonna defang a URL or defang an email? Let's see here. Email. Wrong. Can emails be defanged anyway? Let's see here. Only fully wires everything. Let's try with IP. I don't think it is correct format. I haven't tried this before. I haven't defined any email before. Defang an IP this time. Now we're still getting this. So the @ here, it is the problem, I guess. If we try with maybe @, oh, it worked. Enter your answer in defined format. Format is AAA @ so that was the problem here. We have to replace the @ symbol with its original or with its defanged replacement. Okay. All right, now let's have a look at the last one, Tshark challenge 2 directory. Case directory curiosity. An alert has been triggered. A user came across a poor file index, and their curiosity led to problems. The curiosity killed the cat. Investigate the queries, use VirusTotal. Yeah, typical SOC analyst and threat hunter job. What is the name of the malicious suspicious domain? Okay, Tshark dash R. And let's have a look at the DNS protocol first, the packets. So it starts with packet number 11, and we have these DNS queries. We have A records, and we have these domains. Let's do some sorting. So we're going to use dash T, field extraction, dash E, DNS query, name, dash E, another one, DNS.A, the same drill, eliminate the duplicate lines or the eliminate the new lines, sort, dash R, unique, dash C, and then another sort, dash R. Yep. Let's see what the problem. We forgot the keyword fields. Fields. Now we have a breakdown of the domains that were queried here. So it starts with this domain or this query is a tab, ping. All these domains look somewhat familiar, but this one looks out of order. It sticks out here because it's not familiar. Other domains belong to, known domains such as Microsoft, Ping. So we have this domain. Gonna try to answer with this domain after we defang the URL. Defang. So that was the one. What is the total number of HTTP requests sent to the malicious domain? Let's take a look at the HTTP packets first. So here we use hey HTTP, and we take a look at HTTP packets. So it all starts with packet number 24. And let's see here. We have these URLs. There is a request to an executable file. This looks interesting. There is a request to a new bot target. Okay, being familiar with the requests and the URLs is important before you craft your next command. The next command will be extracting the fields. So dash T, fields, dash E, server, let's extract the value in the server, and dash E, HTTP request URL, and let's also extract the host. Yeah, a lot of mess. I accept it. AWK, OK, NF, sort, dash R, and then unique, dash C, sort, dash R. Okay, so now, oops, what is this? There is a user agent here. What I have extracted in the first place? I have extracted the value in the server, the request URL, and the host. Take a look at this example. So in the value server, there is nothing. The request URL, we have a request to an executable file, and in the host, we have the same suspicious domain. What's the question here? What is the total number of HTTP requests that were sent to the malicious domain? Let's go back. Looks like we have two here. And all of these were requests to the malicious domain. Okay. If we count them, let's use another method here. So we have other requests as well. We have these. So we can do here, we can use an L or a grep, the name of the domain. So we have 14. What is the IP address associated with the malicious domain? Remember, we have extracted the IP addresses of the contacted domains using a DNS or by focusing on the DNS queries. Let's try to do the same here. So here we have to modify this a little bit. Let's go back. Yeah, keep everything as is, the sorting and the awk. Here we're going to focus on DNS query name. And also we're going to extract DNS the A records, and this should do it. So the malicious domain has this IP address. Okay, next one. What is the server information of the suspicious domain? Okay, we're gonna have to go back to the previous command. Remember this one. What is the server information here? We don't have server information, although we specified that we want to extract the HTTP server. But looks like we're gonna have to remove the grep command here. And let's take a look. We have this as a value in the server information field. But to which domain it belongs, we are still not sure yet. How about we only extract the HTTP servers? So we're gonna have to remove the other fields. I'm gonna get back to them. Just get me the HTTP servers. So we have Apache, we have ECS, and we have Kestrel. If we go back, we can see them here as well, Apache, ECS, and Kestrel. Which one belongs to the malicious domain? We can find out by correlating the number of packets. Remember that the malicious domain appears in 14 packets, and we have this server appears in 14 packets. So it looks like we got our answer. Let's see the format. This is the format. I'm gonna have to copy this, and I hope it is the correct answer. It must be the correct answer, right? So submit, yes. Follow the first TCP stream in ASCII format. Investigate the output carefully. So now we're gonna have to follow some TCP streams. To do that, let's go back. Specify the directory name or the capture file name, and then use the option -z follow TCP in ASCII format. The first TCP stream has the index 0-q, and we have the packet. What is the number of listed files? Okay, this one is kinda, let's see here, node 0, node 1. We see the request headers. Okay, let's examine the requests. So we have a GET request to the main URL, and we see the response. This is a typical response. It does include some information here. This is the title, index of. Looks like this is a request to a directory browsing page. And here we can see an image, and there is a reference to a PHP file. Another image which references an executable file, another image which references another PHP file. So in total, we have 3 files up until now. Another GET request to a GIF image, and that's the response. So in total, we have 3 files. I thought it was 2, 3. What is the file name of the first file? It was 123, I remember. I recall it was 123. So it starts here. Yeah, it is 123.php. Defunc. Export all HTTP traffic objects. What is the name of the downloaded executable file? Let's now go to exporting the objects. Remember, objects can be exported with a unique switch, tshark -r directory, and then -export -objects, HTTP, comma, and let's define the directory which will store the object files. In this case, we're going to leave the directory as the same working directory. So I'm going to use -q. Will this work? And we have got the files extracted. The question is asking what is the executable file. So it looks like we got 2 executable files, but they are duplicate files. Your answer is this. What is the SHA-256 value of the file? So here we're gonna have to use some SHA-256 sum of VL auto, and that is the value. Search the hash in VirusTotal. What is the PEID packer value? Let's now go to VirusTotal and do some threat intelligence tasks. So in search, we plug in the hash, and here we're gonna have to look at the details. Under the details, we should find information about the packer used to pack this file. Search for packer, and there it is. It is .NET executable. Search the value or the hash again on VirusTotal. What does the last line sandbox flag is? What does the last line sandbox flag this as? Okay. Let's see in the relations. We should have information about sandboxes in the behavior. Let's take a look at the behavior. We see the sandbox is here, and let's see here the question. What does the last line sandbox flag this as? The question is, I don't know what I got to say about the question, but anyway. Okay, so in here we see the analysis by various sandboxes. We can untick or tick to display the analysis done by the said sandbox. So here it's kappa, this one is last line, the one we are interested in. So let's untick all of them and select only last line. Scrolling down, we see last line says that this is a malware Trojan. So this is it. All right, so that was all of it.